Yeah. All right, sweet. So, um, yeah, man, the official part 1 of my Origins of the Universe project. And so far, I've spoken to Don Lincoln. He gave me a brief introduction into how because normally how I start these projects, I literally have no prior kind of information other than what you get, given to you
Yeah.
from TV and stuff.
Right.
So he gave me an introduction into the whole kind of storyline. Um, what were the first discoveries? What like people using telescopes and such, up to where we are now. So he gave me a bit of everything. I asked him questions like, "What made people look for this?" And he basically was like, "People found out this, and then discovered this accidentally. This took about 20 years to find. We had to wait for technology, etc." And so he's given me that timeline aspect of it. I've then spoken to David Kaplan, who I don't know if you know him. He's the guy who made that particle fever. What do you call it? The particle fever film, which was about CERN and stuff.
Oh, okay. All right. All
Yeah.
right. Yeah. Yeah.
And he works at Johns Hopkins,
Yep.
and his special field is dark energy and dark matter, and that kind of stuff in terms of space. And I literally only asked him dark matter, dark energy type questions.
Right. Right.
So in terms of the observation, like that was to do with energy and matter. That was
Yep.
kind of what I was talking to him about. In terms of the observation of space, and specific stuff that I think you do, I haven't got the details. I
Okay.
have like a rough understanding of like I can't even remember it. It's recorded. That's why it's recorded. But I'm gonna revisit it another time,
Right. Right.
which will then allow me to do some research and ask some follow-up questions later on, when I start having ideas and generating ideas for the music side of things.
Yeah. Yeah.
So yeah, what I normally do is just kind of go, just start, and it's quite organic. I guess it will be it's like a personal lecture to an extent, because I'll be asking questions, but mainly you'll just be teaching me.
Yeah.
And sometimes I may just ask for higher levels of detail and write some stuff down like key names or equations or something like that. So then
Sure.
later on I'll look for it. So I guess yeah, what I would say is, where do you think, or no, sorry, what's the initial question? What is it that you would say your work does in relation to the origins of the universe, if at all, to be honest? Because now you're at Kennedy Space Center. I guess that's the whole space exploration thing. And so how does knowledge we have of the universe and the origins of the universe help people at Kennedy Space Center in terms of exploring the universe?
Well, you can completely unpeel this and go back thousands of years when humans were being really curious and figuring out that, hey, it's better to go hide in that cave at night because we can keep warm, and hey, let's see how to start that fire and cook some meat, and let's see how to figure out other things like sharpening stones and stuff like that, and let's look up at the night sky and start asking questions about what we see. And one of the most obvious things you see is the moon, and it's been there since the very early times back in when the earth was still forming. And the moon itself, it's a beautiful sight to behold. You can see it anywhere on the night side of the earth in great detail. And of course you can see it during the day as well. And the moon is something that's frequently misunderstood, because people think it's you can just see it at night, but you can see the moon during the day. And the dark side of the moon is not the far side of the moon, it's just the bit that's in the shadow. And so you can see the dark side of the moon fine as well. But when you look up at the moon, right, it's a circle.
Mm.
And the circle is like as soon as you start to understand circles, you start to understand math. And you're starting to unravel maths, right? You just look at the diameter of the moon and divide it by the circumference, and you've got pi right there, right? And then you've got angles, right? And angles are your coordinate system. right? When you're looking around and you're pointing over there, that's your coordinate system. And so you start by just looking at the night sky to get an appreciation of fundamental mathematics just by looking at the night sky, because you're curious. You're curious and you want to know more. Right?
So
and then if you keep looking at the night sky, you'll see that some of the stars move around every day, right? You'll see some of the stars are close to the sun, you know, you give them names like Mercury and Venus, and some of these moving stars, you give them other names like Mars and Jupiter and Saturn. And there's actually 7 objects that move with respects to the stars on the night sky and the daytime sky. And it's the sun, the moon, Mercury, Venus, Mars, Jupiter, and Saturn. And that's how we get the days of the week. Right? 7 days of the week. Sunday, Monday, Tuesday is Mars Day. You've got to go into Spanish. It's Martes.
Yeah.
And then you've got Mercury Day.
Yeah.
Thursday is after Thor. We changed it in English, but it's actually Jueves. It's Jupiter Day. You got Friday and Saturn Day. And so
wow.
all of these observations, right? All of these observations that we've known since we've just basically laid on our backs and looked up at the night sky, that it's ingrained. It's absolutely ingrained in our culture. It defines our time. You know, 24 hours in a day is to do all to do with the rotation of the Earth and when the sun gets back to the same point in the sky, right? Lunchtime, the sun's the highest point in the sky. And so we start to see our own exploration of the universe, which is us starting to understand our origins just by lying on our back and asking some very simple questions. What is that? Right? And then, you know, as we kind of lose ourselves, as we start to develop and you know, become more and more technologically advanced, and we start to see technology come into play, right?